I don't want to involve this number because they're both factors. Leave it alone. Can wait patiently. This is enough trouble to differentiate. I don't want to involve those numbers. They will not be. Okay, so then the second derivative equals -3/2. And I have to use the quotient rule here. Okay, so let's do that. Top function prime, luckily, is 1 times the denominator minus the top times the denominator prime. A few minutes ago, you already told me this is 1/2 the square root of 6 minus x times -1 divided by the denominator squared. This is not a friendly situation at all. So let's see how we simplify it. So -3/2, 6 minus x. Can anyone give us the least common denominator in the numerator? I didn't hear the least common denominator. Well, we know there is only one. It's this, 2 the square root of 6 minus x. Like before, 2 the square root of 6 minus x. So then I have, again, 2, 6 minus x. Minus with minus changes into plus. X minus 4. So negative x minus 4 times -1, right? So the numerator only has x minus 4. Okay, and this is over 1 because I will flip it. So now I have a -3/4 in front. The denominator is the square root of 6 minus x as well as 6 minus x. Let's see the numerator. 12 minus 2x plus x minus 4. Ugly, but it is what it is. So -3/4 negative x plus 8 over, I'll put 6 minus x in front, the square root of 6 minus x. You know the negative goes out and removes this one in front. X minus 8 over 6 minus x, the square root of 6 minus x. Long calculations on this problem. Okay, finally this is the simplified form. So now we want the second derivative to either be 0 or undefined. It's already done. We already established that the second derivative will not be defined at 6 because the first derivative is not defined at 6. So that is already done. So when is this expression 0? When x is
eight.
Yes. Excellent. Aww. I cannot even put 8 in there. Fine. No problem. 8 is not in the domain. Even better. I'm super happy of that. For that. Okay. But I still need to study the sign of the second derivative. I refuse to study the sign of this because it's always positive. I refuse to study the sign of this. So the only piece that will give us the sign is x minus 8. So let's plug in 0. Or plug in 4. Or plug in 6. Doesn't matter. But nothing to, only to the left of 6. Plug in anything you want and tell me the sign.
We could plug in 1.
Yep. Or 0. 0 will be the easiest.
And it would be positive. Oh, yeah, I guess.
So it's negative.
Oh, sorry, I was looking at the negative x plus 8 before we.
Oh, no, it was a negative in front. So I simplified.
Yeah, I plugged in the wrong thing, sorry.
Done. Before we graph, there is one other item that does not fit in the chart, in the table, which is symmetry. So we'll talk about that. This cannot be symmetric if the domain is not, I mean, the domain of a function is -6, negative infinity to 6 can never be symmetric. But I'll refresh your memory on symmetry. So, but I need to identify what type of point is 4, 5.7. Once I identify that, I'm ready to graph. 4, 5.7.
A relative maximum?
Of course. Look at the arrows, of course. Excellent. It could also be an absolute. We'll see in a minute. Okay. Now I wanted to tell you that everything we see here is complete gibberish. Meaning, I don't care for it. It makes no sense. Everything I need is right here in the table. I will never look back because I summarized all my information in the table, and the table is all I need to graph. I don't even want to see anything else. I'm not interested in anything else. Don't waste my time with anything. This is it. One, two, three, four, five, six. So I need to plot the points, and the points I have are 0, 0, 6, 0, and 4, 5.7. 1, 2, 3, 4, 5, 6, 4, 5.7. So the function is coming from negative infinity, increasing to the origin, opening down. Coming from negative infinity, increasing to the origin, opening down. Continue to increase to the relative max, still opening down. Still opening down all the way, it starts decreasing to the 0.6, 0. This is it. All my work was summarized in the table. That's all I needed to graph. Any questions on this problem? Any questions? Any questions? Look what I did with my work. I'm kidding, of course. Any questions? Any questions about graphing? Of course, we're going to have more examples. Okay. I'd like to move on. Allow me to plug in. My computer is running out of juice. Okay. We're going to come back, or we can continue right now. We can look at 59 through 66. 59 through 66. This will be the last part of section 4.3. And then we will look at L'Hopital's rule. And I know I owe you that limit.
We do 60.
Oh, you want to do 60. Very good. Let's do 60. F of x equals x squared minus 4 over x squared plus 4. Perfect. Okay. So I get my table going. What is the first concern ever and forever?
Negative.
I think you said a domain. Yes. What is the domain of this function? The domain is given by x squared plus 4. Can anyone give us the domain?
X cannot equal -4.
So it's x squared plus 4. This is always positive. This is always positive. When we add two positive numbers, we can never get anything else.
So x cannot be less than or equal 0.
So when we talk about rational,
X squared plus 4.
cannot be 0. It will never be 0. A positive number plus another positive number, this will never be 0. So it happens that this is a friendly function. Anything goes. Good. Now I have to determine these limits. How do I determine the limit as x approaches infinity from x squared minus 4 over x squared plus 4? Yes, it's infinity over infinity. You can use L'Hopital's rule if that's what you want. If we use L'Hopital's rule, what is the derivative of the top?
It just got really blurry. Oh, never mind. It's better now.
So what is the derivative of the top?
2x.
Good. What is the derivative of the denominator?
2x.
So then the limit is 1. So 1, y equals 1 horizontal asymptote, y equals 1 horizontal asymptote. Good. 0 has to be in the table. If x is 0, what is the function value?
-4.
Yes. Awesome. And now, when is x squared minus 4 over x squared plus 4? 0. Because I need to find the x-intercept as well. This is the y-intercept. When x is 0, y is -1. A fraction is 0 when the top is 0. When would x squared minus 4 be 0? Or when would x squared be 4? And you have to give me two solutions because it's quadratic.
When x is 2 or -2.
Very good. Back to the table. Careful where you place those numbers. Done. This is done. I have the limits and I have the x and y intercepts. Now I am ready to study the first derivative. So let's study the first derivative. Which rule applies here? Quotient, very good. Okay, so quotient rule. Top prime is 2x times the denominator minus the top times the denominator prime. Please do not distribute. Please do not distribute. Factor out 2x. This 2x from both terms. Now, well, what do we have at the top?
X squared
Yes, plus 4. Very good. Yes.
minus x squared
Yes,
plus 4.
exactly. Yay, I love that. 4 plus 4 is 8. 8 times 2 is 16. F prime, either 0 or undefined. This is always defined. None in this case. But when is this fraction 0? When x is? Anyone, please?